Good morning. The reason you're watching a video for today's notes is because I am not here. What I expect is that either on the paper the sub has given you or in your notebook you will be recording these notes. When you start, your title is 15.1 Geometric Sequences. We're going to be looking at a series of numbers and trying to find the common ratio, or what it is we're multiplying by to get the next number. So make sure you have your title, 15.1 Geometric Sequences. When we're looking at these, we're going to be multiplying either by a number greater than 1 or a number less than 1 to get the next number in the series. That's what makes it geometric over arithmetic, because we are multiplying by a number. If the numbers are getting bigger, we're multiplying by a number bigger than 1. If the numbers are getting smaller, we are multiplying by a number less than 1. If we look at our first example, 6, 12, 24, and 48, the numbers are getting bigger. So we're going to be multiplying by something bigger than 1. If you look, it looks like we're multiplying by 2. Let's try that again. 12 times 2 does equal 24. And if we look at it one last time, 24 times 2 does get us to 48. So the ratio that we're multiplying by is 2. If we were not able to see that the ratio was 2, because sometimes the numbers aren't that easy to see, we can follow a formula that says you take the second number in the series, 12, divided by the first number, 6. Well, 12 divided by 6 is 2. So the ratio is in fact 2. Next, we want to find the next three terms. So we will simply continue our pattern with the ratio of 2. So I will take in my calculator 48 times 2, and I will get the next number in the series, 96. Then I will take my 96 times 2, and I will find my next number in the series, which is 192. If I take that number and also multiply it by 2, I will get my answer of 384. Now let's look at the next example that we have. 9, -3, 1, and -1/3. You will see the numbers are going down from 9 to 3 to 1, and the signs are changing from positive to negative. So because they're getting smaller, we're going to multiply by a number less than 1. So to make sure we are getting the right number, we're going to take the second number in the pattern, the -3, and we're going to divide it by the first term, 9. So that would be -3 over 9. When we reduce that in our calculator, that could either be -1/3 or 0.3. So our ratio that we're working with is going to be -0.3. So multiplying by 0.3 or times -1/3 is the ratio that we're going to be working with. So if we try that, that works. 9 times divided by -3 is -3. -3 divided by -3 is a +1. So the idea of dividing by -3 or multiplying by its reciprocal, -1/3, gets us the same results. So we'll continue that pattern. We had -1/3, so we will now multiply that by another -1/3. So that would give us -1 times -1, which is 1 on top, and then 3 times 3, which is 9 on the bottom. So the next number in the series would be 1/9. Once we have the 1/9, we will continue with that pattern, multiplying it by another -1/3. So that would give us a -1/27. Continue multiplying by a -1/3 again, and you'll get a +1/81. So the next three terms would be 1/9, -1/27, and -1/81. The denominators got bigger because we were multiplying just the denominator by 3. Take a moment and look at the next one. From 100 to 50, the numbers are going down, so we're multiplying by something that is less than 1. So our ratio or rate is going to be less than 1. Well, to get from 100 to 50, we're cutting it in half, and we could write half as 0.5. So the ratio that we're going to use is 0.5. If we'd like to prove that it's 0.5, we could take the second term, 50, divided by the first term, 100, and get 5/10, 0.5. So the pattern or the ratio that we're going to use is r is equal to 0.5. So let's continue our pattern. If we're at 12.5 on the end and we multiply that by 0.5 or a half, that would give our next number as 6.25. If I continue my pattern and multiply that times 0.5, I will get a new value of 3.125. I will then take that number in my calculator and multiply it by a half. So I will multiply 3.125 times 0.5. When I do that and I round, I get 1.56. So the ratio we multiplied every number by was 0.5 because that represents a half. So there are our next three terms in that sequence. Please make sure that you are showing all the ratios that you found, how you found them, and then giving me the numbers that are next in the sequence. So when I look at your notes as well as your homework, I expect to see some work that shows me how you found the R. If you need to pause the video at any time, feel free to pause it and write down anything you need. When you're ready, continue on. We're going to look at the next example, looking at a real-life situation. We're going to look at this example of a bungee jumper that's jumping off a bridge. The table represents the bungee jumper's height from above the ground from the top of each bounce. The height forms a geometric sequence. If you are paying attention to the video, you will realize that I just skipped the problem up above, communicating mathematical ideas. If you take a moment and look, it says there's a geometric sequence that has a common ratio of 3. They tell us that the fourth term is 54, but they want us to find the fifth term and then the third term. Well, if the common ratio is 3, we would multiply the 54 times 3 to get our next value. When we do that, we get 162. Now, if I want to go backwards to find this third term right here, I'm not going to multiply by 3 because that would get me right back to 162. So since I want to go backwards, I'm going to undo multiplying by 3 and I'm going to divide by 3. So if I take 54 and I actually divide it by 3, we should get an answer of 18. So you would be recording that when we go backwards, we actually undo it by dividing by 3, and the number is 18. So the third term is 18, and the fifth term is 162 for the fifth term. So I do apologize about jumping and then coming back to that problem. So feel free to pause if you need to go back and get that all copied down. When you're ready, move on, and now we'll look at our bungee jumper who's jumping from the bridge. Let's zoom in so we can take a moment and picture our little person that they have jumped off the bridge and they're going to be bungee jumping down. After we reach the ground or close to the ground and bounce back up, we get up to 200 feet from our original height. If we bounce again, we only bounce back up to 80 feet. Then the next time we bounce and go back up, we only make it to 32 feet. So these numbers, 200, 80, and 32, are represented right here in the table of data. So if you notice, when we have one bounce, that's a height of 200. So we can write these numbers as a series of numbers or a sequence. The first bounce gave us a height of 200, bounce number 2 gave us a height of 80, and after our third bounce, we went up to a height of 32. So there's our sequence of numbers, 200, 80, 32. The numbers are going down, so that means I'm multiplying by a number less than 1. So since they want us to find the fifth bounce, we're going to kind of plan this out and go out to the fifth empty line there and figure out what that would be. We need to find our common ratio. So let's take the second number, 80, divided by the first number, 200. So in our calculators, if we type in 80 over 200, we will get a value that we will use to multiply the rest of the numbers by, which is 0.4. So the ratio that we're multiplying by is 0.4. If I verify that that's true, if I multiply 80 times 0.4, I will also get 32. So multiplying by 0.4 is in fact the correct ratio we want to use. So let's continue the pattern and multiply 32 times 0.4. If I multiply 32 times 0.4, I will get 12.8. So after 4 bounces, we'd be at 12.8 feet. If I continue my pattern, 12.8 times 0.4 again, I will get a height of 5.12 feet after the 5th bounce. So make sure you take a moment that you've written out the sequence of numbers, you have shown how you got the ratio of 0.4, and you have found your answer of 5.12 feet. I would like to see all of this, the ratio, the series of numbers, and your solution. If you need to pause, feel free, and then when you are ready, let's move on. We only have 2 more examples to get through. In this next one, we're dropping a ball from a height of 144 feet. So yes, it's starting at a height of 144 feet, but our series of numbers are based on after each bounce. So after the first bounce, the height is only 72. So yes, 144 is our starting height, but when we write our series of numbers, the height after 1 bounce is 72. The height after 2 bounces, they tell us, is 36, and then after the 3rd bounce would be 18. So if I write that as a series of numbers, 72, 36, 18, I've got the first 3 numbers in my series. Now if we read the question carefully, it says what is the height of the ball after the 6th bounce? So I'm going to put my blank spaces in here. I apologize for the dogs interrupting our video there. Let's go back to where we were. If we have that the 3rd term is 18, so after the 3rd bounce we're at 18 feet, then we need to find what we're multiplying by. We can find the ratio by doing 36 divided by 72, the 2nd term divided by the 1st term, and we will find that as 0.5 or half, because 36 is half of 72. So we're going to multiply each number by 0.5 to get the next number. So if we do 18 times 0.5, we will get 9 for the height after 4 bounces. Take the 9 times 0.5 again, and we will get 4.5. If we take that answer times 0.5, we will find out the height after 6 bounces is 2.25. So the final answer is the height of the ball after 6 bounces is 2.25 inches. Please take a moment to make sure that you have written down the whole series of numbers, as well as how you found the common ratio, the 36 over 72, and your answer. If you need to pause to re-watch or record, please do so, and then just hit play when you're ready to continue on. Our next example is looking at a ball being dropped from a height of 8 meters. The table shows the height of after each bounce. For example, after 1 bounce, the ball reaches a height of 6 meters. After the 2nd bounce, it reaches a height of 4.5 meters. And after the 3rd bounce, we reach a height of 3.375 meters. The question says, how high does the ball bounce after the 4th bounce? So we need to simply continue out 1 more in our number series to find the 4th bounce. Well, first we have to find out the common ratio. What did we multiply 6 by to get 4.5? Well, since the numbers are going down, that means I'm multiplying by something that is less than 1. So let's take our little formula and do the 2nd number, 4.5, divided by the 1st number, 6. And when I divide those 2 numbers, I find out that the common ratio that I'll be using for this problem is going to be 0.75. So 0.75 is what we are going to multiply each term by to get the next term. So 4.5 times 0.75 would get us to the 3.375. So our common ratio is the 0.75. So if we continue on with that pattern, we will see that every time we multiply by 0.75, we get the next number. So 3.375 times the 0.75 tells us that the ball reaches a height after 4 bounces. Its height is at, grabbing my calculator really quick, the height ends up at 2.53 meters. If we follow the directions and round to the nearest tenth of a meter, it would just be 2.5 meters. So again, please make sure that you are recording the series of numbers, how you found the common ratio, as well as the final answer in the solution that it has asked you to find. If at any time you need to pause, feel free to go back. Once you have finished these notes, my expectations are that you are going to go into HMH and you are going to begin your 15.1 homework. Make sure you are on your best behavior, please.